Got an interesting one here. I'm hooked up on an LG Mini right around the corner. And you see these sensor values are not making sense. So we have the air at 430, suction, discharge, all of these are maxed out. Now with an NTC, if you've got an open, that's going to show your max logic cold temperature. In this case, we're getting our max logic high temp. So what that means is that most likely the 5-volt reference is going to be shorted to ground, just completely pulled down to 0, which means when we go over here messing around on these connectors, we would see 5 volts on some, such as, you know, right in here, but on others we're going to see 0 volts. And in that case, if we unplug the sensor and that voltage doesn't return, then that's an internal short on the board. All of the temp sensors are going to be on these plugs here. So if we go over, unplug that, let me get that there. Now what's cool here is you'll notice that any of the sensors that were reading accurately before are now going to be reading, see, the max negative. All right, so the code here, this is for the air temp sensor, this one right here. And here's what's interesting about this. All right, now not all of these sensors are populated, so you're going to have some that act like they're unplugged. This unit doesn't have 2 heat exchanger temperatures, so you're going to see that that's not going to change. But this one here, that's accurate, it's at 69, has now gone max cold, right? Because in NTC, it's going to be showing high resistance, or that's what the board's going to read. So that's max logic for the cold sensor, or cold temperature sense. Anyways, let's see here. But you'll notice that this one doesn't change, or else changes just an insignificant amount. So looks like we have an internal issue in the board. And I bet you if we go over there and measure it, there's going to be no logic voltage even coming out on the pin that feeds this air temperature sensor. Now, when you're looking at logic voltage, your ground reference is extremely important. Not all boards are going to share mains ground with DC ground. So I'm actually grounded on the ground for this capacitor so that I can read an accurate voltage. And this is a known good sensor on this unit, which is the coil temperature sensor, and you can see we're about half range, which, yeah, makes sense, you know, for about the ambient. So if we go over here and start looking at the air sensor, I've got nothing on that circuit. So that's going to be a problem for sure. And it looks like because there's no change when we unplug it, that the problem is actually internal to the board. Because if the sensor was shorted, if the sensor itself was shorted, you unplug it, then the board, it's going to show like a negative voltage, right? Because your resistance is going high. All right, so here's the sensor. We're going to short to board ground. All right, go ahead and short it out. Take a second to update. There, so it just went high. And again, that's because if you're going to pull down that 5-volt reference, then the board interprets that as low resistance, which, like I said, on an NTC, is going to be a very high temperature. So this is the max temperature that that board is capable of reading. Now here's what that looks like shorting out that sensor. Now you notice I have 9 slots, or 9 pairs, possible pairs up here, and I've got 9 caps. And again, board topography has a lot to do with function. So I'm gonna guess that those 9 caps right there are responsible for filtering the signal on these sensors. If one of those caps is shorted, it'll absolutely cause what we're seeing. Went ahead and trimmed a few caps off because the board's already screwed. I mean, it could be repairable if it's just a cap shorted out, but like this unpopulated slot on that yellow connector is this cap right here. 5 volts on that. But if I go over here to this unpopulated, honestly it doesn't matter either one. I'm just gonna read logic voltage on the others. Nothing. Well, this board might be repairable after all. Kind of wish I hadn't trimmed the caps off. that can be fixed too. Just a pain in the ass. But somehow these little SMDs got pushed off the board, and there's something, it was almost like something was laying there and just scraped them off. But see, a lot of times your output, which may honestly be from this chip, it's going to feed through a resistor. It has to. That's how those circuits work. So yeah, that could for sure be the issue. Well, let's get that soldered up and might bring her back to life. I'm not going to film the soldering because it's going to be ridiculously hard, especially these. In hindsight, I should not have cut those off, but I didn't think that it was a huge priority to get this unit going. Apparently it is, so we decided to take the board off. I mean, anyways, I'm gonna fix that with this Milwaukee gun with this tip and these tweezers here. Here's a look at these right here. These are the little resistors, and the way these circuits work, you have to have a resistance because the chip's gonna be looking at the voltage drop that happens across where that resistor is and the sensor is. Now, and let me clarify, when I talk about the 5-volt reference being shorted, it could also be open. It's just, it's not there. The chip is not seeing what it should be seeing. Here are these capacitors. That was very, very difficult to solder, but I'm getting the hot snot ready to go, and we'll support these. While the hot snot is baking down there, I'll just go over this circuit. I need to draw it out so it's not so confusing when I'm talking about it. But so you have an IC here, and that's going to put out a 5-volt reference going through a resistor and then to the sensor, and it's going to measure voltage at this point. So if you have a short here, it's going to see 0 volts, or if this is open, it's still going to see 0 volts. So either way, you know, when I was talking about it being shorted, another option is just for it to be open. But what I meant was the 5 volts is not there. It's not making it out to the circuit. Now, shorts are real common, but you know, and I guess it was a wire. I mean, I'll have to go back and look at the footage, but I'm not sure what was like laying back up in here that would wipe those surface mount resistors off the board. You can see where I've supported those caps right there. And then if I go up here, oh yeah, we might have just repaired this sucker. Let's look at it on the computer. Well, she is running, so that's good. Hasn't done that before. Not really sure what the condition of this unit is. I haven't seen it run before, but we'll check it out. All right, we're reading accurately now. The unit is running. I'm not here to check it out and see, you know, what the refrigerant like and all that, just to get it running really. They can schedule a service if they need that. But I'm gonna go ahead and set these indoors to run, and I think that's it.